Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Let us generate a recurrence relation for this one and find the answer for it. Let us solve it also. If I say this is Tn is the time taken, then actually we want for the statement. So this is n because it's in this loop. Even if I consider this for it's of no use, it's n plus 1 only, right? Then this is T n by 2 because it is recursively calling itself for n by 2. This is also T n by 2 and this is also calling recursively itself for n by 2. So for n how much time? Then for n by 2 how much time? So when for n, Tn is the time. For T n by 2, Tn by 2 is the time. Then all these things put together will give you the time for this. So Tn is equals to 2 Tn by 2 plus n. Recurrence relation is Tn is equals to 2 Tn by 2 plus n for n greater than 1. For n equal to 1, it is some constant, or let us say 1. Take this and solve this one. Tn is equals to 2 Tn by 2 plus n. This is the first one. I have to substitute this. So Tn is equals to 2 as it is in bracket. How much this will be? 2 Tn by 4, so 2 square plus n by 2 plus n as it is. So this I have substituted right from here to here. Then if I open this, this is 2 square T n by 2 square. This 2 gets cancelled and it is 2n. 2 gets cancelled, n. Outside this, one more n is there, so 2n. So this is the second equation. Then third equation, I will directly put it here. So it will be 2 cube T n by 2 cube plus 3n. Then if I continue it for k times, Tn is equals to 2 power k T n by 2 power k plus kn. Fourth equation. Now assume what we were assuming. We were assuming that this has reached till 1 because this C for Tn, this is the large value. For n greater than 1. This is a small value, n equal to 1. An answer we know it is 1. So direct answer we know for a small value. So we are assuming that we have to go on reducing this one till it has reached 1. So we assume that n by 2 power k is equals to 1. This has become 1. So n will be equal to 2 power k and k will be equal to log n base 2. Alright. So these two equations we got, or formulas you can say. So these are the outcomes when we assume this. These are the outcomes. Now let us substitute that one here. Tn is equals to 2 power k is what? N. And this is what? T1 because we are assuming that this has become 1. And this is n. So k is how much? Log n. So it is log n into n. So n into log n I am writing. Then this is how much? T1 is how much? 1. So this is n plus n log n. So which is the higher term? Highest degree term is this one. So this is theta of n log n. That's it. This is the answer. Take this one. Okay. So for this recurrence relation, 2Tn by 2 plus n is n log n. This is the answer we got. Now, Master's theorem for dividing functions. Master's theorem for dividing functions. Master's theorem for dividing functions. Now, we assume that the general form is Tn is equals to a t n by b plus f of n. A t n by b plus f of n. This is dividing, right? And that is f of n. Whatever is multiplied is a. If this is the general form, now for any recurrence relation of this form, we want to give direct answer without solving the whole thing. If we need a direct answer, we want to give a direct answer. If we want the final expression, like just now we got the expression as n plus n log n. If we want that answer, then we can substitute and get the answer. Otherwise, if we want direct answer, then we don't have to solve it. Without solving, we want to give an answer. Let us see what this theorem says. See, there are three cases in this one. Case 1. First case. Just a minute. We have to find two things. First one is log a base b. Find out this one. And second thing is power of n in f of n. That is, if f of n is equals to n power k log n power p, so we want k. We want k. If f of n is in some form, then we want power of n. See, I am including log also, means if log is also there. If log is also there. If log is not there, means this is 0. If n is not there, even n is not there, means n power 0 it is, right? So if it is there, then we don't consider log, we consider only power of n. This is important. Again, log a base b you find out, a base b, and power of n in f of n, whatever f of n is, in that power of n you have to take, right? If you have log n also, ignore that. Got it? Now, next, let us look at the cases. First case. First case. First case says that if the value of log a base b is greater than k, log a base b is greater than k, then answer is theta of n power log a base b. Direct answer. If log a base b is greater, then take the answer, right? Then second case. If log a base b is equal to k, log a base b is equal to k, right? Then the answer is n power k or n power k into log p plus 1 n. This is nothing but theta of f of n into log n. Log n is already there, power is there, plus 1 you have to do, right? And in this one more case is there, if p is less than 1 or less than 0, p is less than 0 means p is negative, then theta of f of n power log a base b into log of log n. This is the answer. So this can be taken as if p is equals to minus 1. If p is less than minus 1, then theta of n power log a base b only. Then this was for if p is greater than or equal to 0. P is greater than or equal to 0, this is the answer. If p is equal to minus 1, then this is the answer. If p is less than minus 1 also, then this is the answer. So all these things we will see when we take the examples, right? Then third case, case 3, right? This, if log a base b is less than k, then answer is theta of just f of n. Copy all these things. I'll be removing everything. I'll just keep cases and I'll give you examples here. I'll give you examples, right? So this portion I am going to erase. This is important. You have to find log a base b and power of n in f of n. So this is important. This you have to keep in mind. These are the three cases. This is not so complex how it looks like. It's not so complex. Okay. So one or two examples I'll show you from here. Then directly how to get the answer I'll show you. And you don't have to remember all these things. It's not that difficult. I'm removing all these things so that the board should be clean, so that you can focus on what we are learning. Now, Let us take an example. Tn is equals to 2 Tn by 2 plus 1. This is the example, right? So from this, let us find out what are the things we need. A, B, K. So there is no n here. So let us write it in that form. 2 Tn by 2 plus n power 0 is 1, right? So now I can find out A value, that is 2, B value, that is 2, and K value, that is 0. That's it. So I got all three values. That way I'm going to check them. Log A base B and K. So I got the answers. Now, log A base B is how much? Log 2 base 2 is 1. Now, log A base B versus K. Log A base B value how much? 1. And K value how much? 0. So this one is greater than this one. This one is greater than this one. Log A base B is greater than K. We know the answer for log A base B. That was just A and B. So I have found out log A base B also. So, okay, let me write here. Log 2 base 2 is 1. Now, this is 1 and that is 0. So this is greater than this one. So it comes under which case? It comes under case 1. That is first case. So answer is n power log A base B. So this is case 1. This is under case 1. So answer is theta of n power 1. What is 1? This log A base B, right? This one, n power 1. So this is nothing but theta of n. Take that example. So that is an example for case 1. Case 1 completed. Now I'll take the example which fits in case 3. Right? Then after that I'll show you case 2 because there are multiple things inside case 2. So let us finish the simple things first. So this one. Tn is equals to 2 Tn by 2 plus n square. What is A? This one. A. 2. What is B? This one. B is 2. Then what is the K? Power of n in f of n. This portion is f of n. Power of n is how much? 2. Now what is log A base B? So 2 base 2 is how much? 1. 2 base 2 is 1. So we know all these things, right? Now find out log 2 base 2 versus this is 2. Who is greater? Who is greater? This is 1 and this is 2. So this is less than this one. So this portion is greater. This is less than this one. So this is coming under case 3, right? Log A base B is greater. So what I have to take answer? Answer is just f of n, n square. That's it. Take that one. Next, take the example of this one. Tn is equals to 2Tn by 2 plus n. A is 2, B is 2, power of n, k, this is 1, this is 1. Find log 2 base 2, that is also 1. Log 2 base 2, that is log a base b, is 1. Then log 2 base 2, that is 1, and this is k. So this is 1, this is 1, so both are equal. If they are equal, then the answer is what? There are three cases again. P is greater than or equal to 0. What is that P? P is you have to check whether this log n is also there. Log n is not there. I will write log n. Log n power 0. It is there, but power is 0. So P is 0. So then what is the answer? F of n into log n. F of n into log n. Or n power k. N power k. K is what? 1. N power k. K is 1. Then log n. P plus 1. P plus 1 is what? P is how much? 0. So here I will write P also. P is 0. So P is 0. So 0 plus 1 is 1. So this is theta of n power 1 is n only. Log n power 1 is log n only. Answer is n log n. In other words, what is f of n? This is not there in f of n, right? This is not there. N into log n. That's what I have told you, that f of n into log n. Simple. F of n into log n. This explanation was with respect to the cases written here. These are the cases that you find in textbooks. So I have followed the textbook approach to explain you. Over, right? So till now, I was following textbook approach and I have shown you all three cases. Alright? And the cases are there on the board. Now, I will follow my method to show you the answers, direct answers. Just watch it. In that, we will come across these two also. These two also. Oh, you have to copy this one, sorry. A, B, K, log 2 base 2 and P, 0. Next, Tn is equals to 2Tn by 2 plus n log n. Let us solve this. A is how much? 2. B is how much? 2. Power of n, k is how much? 1. And p is how much? 1. P is also there. 1. This is also 1. This is also 1. Now we have to compare log 2 base 2. That is 1. Alright, that is a base b. So log 2 base 2 versus k, this is also 1, this is also 1. So both are equal. So they comes under case 2. Case 2. Then, I told you that when it is in case 2, whatever this f of n is, take it and just add into log n. So if you add one more into log n, So if you multiply log n, if you multiply log n, then it will be log square n. So n log square n. So whatever it is, as it is you take, then multiplied by log n. So multiplied by log n is log square n. So that's what, whatever p is plus 1 means log n is multiplied. So this I have shown you, right? So we are still here. We are still here. So directly we can get the answer. So if already log n is there, then it will increase by 1. Its power will increase by 1. Take it quickly. Next, look at this. This is n by log n. Log n is in denominator. So this is minus 1. So it means this portion is just like what? N into log n power minus 1, right? So p is minus 1. P is minus 1. Okay? Then, when the p is minus 1, this is the answer. Log a base b, or k also you can take. K and both are same only, right? Log a base b and k are same. So I wrote log a base b and log of log n. So what is that? Theta of n power 1. Then into log of log n. Log of log n. So if log n is in denominator, then you get log of log n. So that is in case 1. Sorry, case 2 and this sub case of that one. Case 2 sub case if p is equal to minus 1. So log n is in denominator, then this will be the answer. So take n as it is, but don't say into log n gets cancelled. So you cannot follow this one. F of n into log n, you cannot follow this. It will become log of log n. Okay. Then third one. Okay, you finish this one first. Copy it quickly. Next, if this is log square, means this is minus 2, this is minus 2. Now, p is less than minus 1, Then, this is negligible, log square n, denominator. See, n by 1 is n only. So, if in denominator, if you have a very small value, then it's almost like 1, Alright, so this is log square n. So then this should be taken as what? Just n. Theta of n. So if you simplify that also, because it is square, so you remember this equation. 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. So this is 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus 1 by 2 4 goes on to 1. So in the denominator, when you get a sequence, so that denominator almost becomes 1 only. It will become 1. So if you solve it also, that value will be negligible for you. So answer is just n power k or n power log a base b. Any one thing you can write, both are equal only. So answer is 1. So this was the third one in this case 2. Tn is equals to Tn by 2 plus n. Tn is equals to Tn by 2 plus n square. Tn is equals to 4 Tn by 2 plus n square. Tn is equals to 2 Tn by 2 plus n square log n. Tn is equals to 4 Tn by 2 plus n square log square n. Tn is equals to 9 Tn by 3 plus n. 1. Tn is equals to okay, this is n only, you take it as sure. Then 5 Tn by 2 plus n. I'll remove this, you know the cases, right? So this space I will use for writing the answers. Find out the answers for these. Log a base b, log 1 base 2 is a 0 and k is how much? 1. So who is greater? This one. So this comes under which case? Third case. So answer is how much? Theta of n, just f of n. Here, log a base b, a is how much? 1, b is how much? 2. So this is how much? 0 and k is how much? 2. Power of n, right? Power of n is 2. So this is theta of f of n, whatever f of n is. This one. Case 3, coming under case 3, right? Then log a base b, 4 base 2. A is 4, b is 2. 4 base 2. This is how much? 2. And k is how much? N square. So that is also 2. Both are equal. This is coming under case 2. Both are equal means case 2. And this is greater than or equal to 0. P means log n is not there. So it means log n is 0. So this is theta of n square log n. N square log n. And this one, log 2 base 2 is 1. N square. So k is how much? 2. So answer is how much? Whatever f of n is. First of all, tell me which case it is coming in. This is coming in which case? K is greater. So this is in k is greater than log 2 base 2. This is coming in third case. So the answer is theta of n square log n only. F of n. Then here, log 4 base 2 is how much? 2. Log 4 base 2 is 2. And power of n is how much? 2. Power of n is how much? 2. Then this is coming under case 2. Case 2 means what? Theta of whatever f of n is, n square log square n into log n. Into log n means this square becomes what? Cube. Then this one, log 9 base 3 is 2 and power of n, k is how much? 1. So that is greater. This is coming under case 1. So the answer is how much? N power log a base b. How much? 2. Then this one, log 5 base 2. So 5 base 2 is how much? Log 4 base 2 is 2. 5 base 2 means 2 point something. So let us say 2.1. Just assuming. And k is how much? 1. K is 1. Who is greater? That one is greater. Log a base b is greater. So this comes under which case? First case. So what is the answer? Theta of, this is n power log 5 base 2. Instead of writing, we don't know the exact answer, you should calculate. Instead of writing exact answer, I am writing log 5 base 2 only. That's 2.1 or 2.2, whatever it is. So you can take it. Over. That's all. That's all about recurrence relation and master's theorem. So we have seen some practice questions also, right? So we have found out the direct answer. So it's very easy. Master theorem is very easy. You should not look at all these things. Just you take some examples and solve them by yourself. Already I gave you some examples. You spend some time on them. So if you can solve them, directly you know the answer, right? So you don't have to think case 1, case 2, where it is going. So you can easily see that. So you will get used to with the cases, right? So this is very simple. Once you need to spend some time. Otherwise it looks very tough. So many cases, how to identify cases and all. So simple method I have shown you. Find log a base b and power of n. That will give you the answer. There are many gate questions on this one. Recurrence relation, what is the time complexity? So you have to apply master theorem and get the answer. So gate questions are there in this one. So this is very important topic in gate, right? Now, we will come back to divide and conquer method that we were discussing. In divide and conquer method, we need recurrence relations because divide and conquer algorithms are all recursive. So to find the time complexity, we need recurrence relations. So we have learned what are recurrence relations and how to solve them, how to get the answer, asymptotic answer we have seen. And we were getting all the answers as a theta only. The reason is we know the equation finally. So it belongs to so and so class. We were using theta. If it doesn't belong, then you can say big O or omega. Alright. So that you have to judge and take it. So sometimes you may write big O also there. But most of the time we write theta. So I have written theta there. Now, we have to continue our topic. So in this, I am going to discuss finding maximum and minimum. Finding max and min. Let us see this problem. So I am going to cover this topic just like how it is found in the textbook, right? I am going to follow textbook style. Okay, this topic is there in the textbooks. You will find this book, this topic. The reason is to make you understand how to apply divide and conquer. And if you don't use divide and conquer, if you use a normal method, then what is the difference? This is a discussion done in the textbooks mostly upon this topic, right? So this problem is taken to study divide and conquer strategy. All right, not to solve a problem. Problem is simple only. Just to study divide and conquer it is taken. So I'll take the same approach. Alright, and gate questions, there was just one or two gate questions are there, that is asking the time complexity of this one. But this will give you the idea how divide and conquer strategy can be applied and how you can solve a problem. That also you get the idea. So let us start. I will give you that same approach. So we are understanding divide and conquer strategy. What the divide and conquer strategy says. So if I repeat, divide and conquer strategy says that if the size of the input is very large, problem is large, then divide the problem into sub-problems, solve those sub-problems, combine their solutions to get the solution for main problem. So that's what we will learn now. Okay. See, I have an array of elements. Indices starting from 1 onwards, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, some elements. 8, these are the elements. 3, 6, 4, minus 5, 9, 13, 16, 12, okay, 17, then 5. Now from this you can find out which is the largest element. 17 is the largest element. Which is the smallest element? Minus 5 is the smallest element. Now what is the method for finding both maximum as well as minimum if I want to find out what is the method? So let me write down just a piece of code here. So I will take one variable, say max, and I will say this is the first element. I will take first element in that one. Okay, I'm writing the code, algorithm code. I'm not writing complete algorithm, just a piece of code. Then I will take one more variable minimum, and to that one also I will assign this first element. So both max and min are the two variables which will be having value 8, 8. So I will take the variables here, that is max, that is 8, and the min, that is also having value 8. Now, I'll go through this array. For I takes values from 1, I is less than or equal to n, I plus plus. Now already first element already taken, so let us start from second element onwards, okay? Because first element is there with them. Now second elements onwards we'll check. So what we check is, if this element is greater than maximum, then this will take its place. If this is greater, it will take its place. If this is greater, so they are not greater, they are not greater. This is greater, so this will take the place. This is greater, so it will take. So whenever any element is greater than maximum, then maximum should be modified, right? So in our example, you can see that when we come across 9, 9 will replace 8, right? It will be changed to 9. Same way, for minimum, we should check that. Is this number minimum? 3. Yes, 3 is minimum, so that will change to 3. Then 6, 6 is not minimum, then 3. 6 is not minimum, then 3. Then 4 is not minimum. Minus 5, yes, it is minimum. So minus 5, then 3. Then 9 is not minimum, 13 is not minimum, 16 is not minimum, then 12 is not less than 15, sorry, minus 5. 17 is not less than minus 5. 5 is not less. So that we got minimum. Okay. Similarly here, okay, I did not show you this. 9, 13 is greater, so change it to 13. 16 is greater than this, so 16. Then 12 is not greater than 16, don't change it. 17 is greater than this one, 17. 5 is not greater, don't change it. So we got the maximum answer and minimum answer. So what I'll do here is, if any element a of I is greater than maximum, then change maximum to a of I. Then if any element a of I is less than minimum, then change minimum to a of I. That's all. Take this one. So this is the simple code. Whatever I have explained you, code says the same thing. I have explained you the code. So this is the simple algorithm for finding maximum minimum. You take this one, then I will tell you the analysis, then some changes, then we'll go for divide and conquer. This is the straight min-max or max-min algorithm. This is the straight method using loop. There is no divide and conquer strategy. There is no divide and conquer strategy. Now, let us analyze this one. Analysis for what? See, we have been analyzing, right? Many algorithms we have analyzed. In that I was giving the statement and said what is the time for this one. Otherwise, every statement we considered sometime, right? Initially, every statement we considered. Later on, I was writing some statement, STMT, some statement I was writing. I was asking you how much time this is taking. Now here there is no STMT. What you will analyze? What you will analyze? Shall we analyze each and every bit? This is not a complete algorithm. Anyway, I just write algorithm and it becomes a complete algorithm. Everything is there here. Everything is there here. Okay. So shall we consider initial wave statement? No, we want just important statement. So that's it. Till now I was writing some statement there, some blank line I was writing. I was saying find the time for this one. Now what you will find here. So what is the major work in this one? Major work. Loop. Loop will repeat for n times. So order of n. Yes, it's order of n. Order of n. Time is order of n directly if you see. But inside this, the statements are there. What is that? Condition assignment. Condition assignment. So what is important? Condition is important. Yes, condition always it is checked. And under that, whatever the statements, they may or may not execute, but the conditions are always executing. So let us check how much time it will take for this algorithm. So actually we want to count how many comparisons are done. So let us take. See this, there are n elements, right? N elements are there. So where n is 11 here, n elements are there. And from this n elements, except the first one, second elements onwards, it's comparing all the elements. So total how many comparisons this is done? N minus 1 comparisons. N minus 1. Then what about this comparison? This also will be n minus 1 comparisons will be done. So total 2n minus 1 number of comparisons are performed. So number of comparisons